Q7 of May 2022 Paper 1. So we're told that a continuous random variable x has probability density function f of x equal to k over radical 4 minus 3x squared when 0 is less than or equal to x less than or equal to 1. In part A, we're asked to find the value of k. Okay, so this is the procedure to find k itself is rather easy. You just have to solve for the integral of f of x equal to 1, because this is a probability density function, and so p, the probability, will equal to 1. So in order to find the probability, you have to take the integral of f of x. So the integral of f of x, we know that it is equal to 1. We know the boundaries as well, right? So the only step that requires thinking is solving the integral itself. So k over radical 4 minus 3x squared dx equal to 1. Now for this, I'd recommend you use substitution. And so if you take a look at your data booklet, topic 3, trig identities, you'll see that cosine or sine is equal to 1 minus radical 1 minus sine squared of x, right? So we know that cosine squared of x plus sine squared of x is equal to 1. So you can use this, right? But for x, you have to consider x as a value that you can cancel out the 3 and somehow be able to factor out the 4 from the radical. So you only have 1 minus, let's say, sine squared of x. Okay, so I'll consider x as, and also don't forget that the x is squared. So, let's see, we can consider it as 2 over radical 3, right? So when you square it, the 2 is going to be a 4, so you can factor out the 4, and the radical 3 in the denominator is going to be 3, which will cancel out with the 3 right here. So 2 radical 3, let's go with, what's cosine or sine? Let's go with sine. Sine of u. Sine of u. So 1, 0, k radical 4 minus 4 sine squared of u dx equal to 1. So you'll factor out the 4, so you'll get 1 over 2. You can bring out the k as well. So let me bring out the k for simplification. Okay, so we'll have 1 over radical 1 minus sine squared of u, which is cosine of u okay, so we have to get rid of dx. So if we take the derivative of this, it's going to be dx over du, 2 radical 3 cosine of u, right? So dx will equal to 2 radical 3 cosine of u du. So let me erase this. Alright, so 2 over radical 3 cosine of u du equal to 1. Right, and so the cosine of u's will cancel out. The 2 will also cancel out with this 1 over 2. So really we're left with what are we left with? K over radical 3, the integral of 1 du, or you can say the integral of du, which is simply what, u. And so this will be k over radical 3 u equal to 1. Now Now, again, you should not forget that this has a boundary, right? And so you can find for the value, you have to substitute in the u, right, in here to solve for k. So u is equal to radical 3 over 2. I'm just using basic algebra to solve for u. So u is equal to radical 3 over 2 x. Now this is sine, then arc sine of, so arc sine of radical 3 over 2x is equal to u. So you can substitute that. You get k radical 3 over 2, or k over radical 3 arc sine of radical 3 over 2, right? And I'll just substitute in 1 right now. Then that's it, I guess. Go to 1. What else can it do? Oh, okay, yeah. So you can multiply radical 3 to the right side. So you'll be left with sine inverse of radical 3 over 3, 2 equal to radical 3. Now what? What's sine inverse of radical 3 over 2? Well, that is easy. It's pi over 3, right? It's k pi over 3 radical 3, and so k will equal to 3 radical 3 over pi, I think. Let us check. Allow me to check. Fingers crossed. Come on. Yes! That is correct. Okay. Okay, so now in part B, we're asked to find e of x, which is the expected value. So in order to find e of x, you should take the integral and solve the integral of x, f of x dx. So it goes to 0, 1. So e of x will be x times, we now know k is 3 over 3 times radical 3 over pi. And there is also a radical 4 minus 3x squared dx. Okay. Lovely, how lovely. Okay, this is honestly my first time solving this. I'm not sure what to do. I mean, if we let's use substitution again, right? And I'll consider u equal to 4 minus 3x squared, because that way I'm thinking I can also cancel out the x here as well. So du over dx is negative 6x. This should be fine. Okay, so dx is, oh no, oh yeah, so du over negative 6x, there we go. So e of x will be integral, and then x times 3 radical 3 pi radical u times du I'll just bring out the negative, so 6 du 6x, right? And so the x cancels out, the 3 and the 6 cancel out, and so we'll have a factor of negative 1 over 2 pi, the coefficient, and then we'll simply have, oh, there's also radical 3, so we have radical 3, negative radical 3 over 2 pi, the coefficient. Then inside the integral itself, we'll have integral of u to the power of negative 1 over 2 du. So if you solve this, it's gonna be u to the power of negative 1 over 2 plus 1, simply 1 over 2, right? So u to the power of 1 over 2, and this divided by 1 over 2, so again 2, hopefully. And so the 2's cancel out, right? And there's also a boundary of 1 to 0 here. So the answer is negative, the simplified answer is negative radical 3 over pi times u to the power of 1 over 2, and now we know u is 4 minus 3x squared, so you can substitute that in here as well. So if we now solve for the given boundaries, we'll get radical 4 minus 3, which is radical 1, which is simply 1. So negative 3 over, negative radical 3 over pi, and then minus negative radical 3 over pi, which is positive, right? Positive radical 3 over pi, then radical 4 minus 0, which is 2. So that's going to be 2 negative radical 3 over pi plus 2 radical 3 over pi, which is radical 3 over pi again. Seems a bit ambiguous. Huh. Well, there we go, I guess, the expected value. And I mean, it makes sense. No, I don't know why. Okay, so there you have it.